Hi everyone and welcome back. So this here is part 2. There was a technical error with the part 1, so I'll just get going. So let's take a look at first ionization energy. So as you go down the group, now remember these group 2 atoms are trying to lose electrons, and so as they go down the group, more energy levels, more shielding, less attraction to nucleus, and easier to lose electrons, easier to remove electrons, and so that makes the ionization energy decrease as well. Okay, let's take a look at electronegativities. Now this is the ability of an atom to attract a shared pair of electrons to itself. Now obviously there's more energy levels, more shielding, and so these shared pair of electrons will be less strongly held to the nucleus due to this extra repulsion, due to this increasing repulsion as you go down the group, and so it will less readily, or it will be less able to attract that shared pair of electrons, and so the ionization energy will decrease. Okay, so let's handle first melting point as you go down the group. Now this relates, of course, now since they are metals, we can expect that trend in the melting boiling point. However, to go specific to group 2, okay, and metallic bonding as you go down, okay, these valence electrons that are in that delocalized pool are less strongly attracted to that nucleus, and so they will be less strongly held together in that sense, and so that metallic bonding is less strong. So yeah, that's just something to think about. So the stronger the metallic bonding, the harder to remove the cations. However, the size of the cation increase as you go down, but the charge remains constant, and so the charge density thus decreases, and that attraction to these delocalized electrons decreases, and therefore the melting point and hardness decrease, I guess. Okay, but the overall trend is for melting point to decrease down group 2. They will conduct electricity because they are metals. Okay, so let us handle and tackle this tricky part, so which is the reaction of group 2 elements with water. M plus H2O. Now magnesium reacts with steam only. However, all the other group 2 elements, I believe, react with liquid water, and that gives the group 2 element 2 plus H2 gas. Okay, so there we go. That metal reacts with water to form hydrogen gas, and that compound here. The vigor of these reactions depends on 2 factors: how easily 2 electrons can be removed from an atom, and as we said, okay, as we go down the group, these electrons are held less tightly to the nucleus, and so they're going to be easier to remove. So as you go down, it's going to be easier and easier to have that reaction, and how soluble the hydroxides of the metals are. So hydroxide solubility goes from least to most as you go down the group, and sulfates goes from most to least as you go down the group. That's just something to think about. So most to least for sulfates, and for hydroxides, least to most. Okay, let's carry on. Since ionization energies decrease down a group, we established that because shielding increases, repulsion increases, less likely or less able to hold that shared pair of electrons closely to its nucleus, and so therefore makes the ionization energy decrease. Okay, so that reaction with water becomes more vigorous as you go down the group. That makes sense. Since beryllium hydroxide and magnesium hydroxide are so insoluble in water, the hydroxide form remains on the surface of the metal, preventing further reaction. Thus, the reactions of magnesium and beryllium with water are very slow. These are more soluble, and so that does not prevent further reaction. So since hydroxide solubility increases down the group, that's what we said, so does the rate of reaction with water. So the reactivity to water increases down group 2. Seems reasonably fine, I guess. Let's carry on. So, beryllium does not react with water or steam. Magnesium reacts with steam only. Since magnesium hydroxide actually decomposes at high temperature into the oxide, magnesium oxide is the main product when magnesium reacts with steam. Okay, so we're not looking at hydroxides for magnesium, we're looking at oxides. And remember, gas, so we're looking at steam only. Calcium reacts normally with cold water, and it forms the metal hydroxide with hydrogen gas. Okay, so the solution goes cloudy as this hydroxide is not very soluble. Remember, as we go down the group, solubility increases. Okay, these strontium and barium, so these are much lower on the group 2. They react more vigorously with cold water. Barium even more vigorously than strontium. And they still form the hydroxide with hydrogen gas with the liquid water. Okay, so let's take a look at the solubility of compounds of group 2 metals. So we already established that as we go down. Okay, as we go down the group. Okay, let's ignore what I just said. So the compounds formed are predominantly ionic. Solubility of ionic compounds depends on the balance between the attraction of the oppositely charged ions to each other and the attraction of the separate ions to the water. If the attraction of the ions to each other is stronger than their attraction to the water, the compounds will not be soluble. And remember, at the top of that group, okay, the electrons are held much strongly to the nucleus, and so the metallic bonding in there is going to be much stronger, okay, and so that attraction between the ions is likely to be stronger than the attraction between the ions in the water, and so that makes it not soluble, and therefore the precipitation reaction will occur. If the attraction of the ions is stronger, the compounds will be soluble and no precipitate will be observed. So trend in solubility of sulfate. So we established that as we go down the group, it's from most to least, so it decreases the solubility. This is soluble, magnesium relatively at the top, but it goes down and down to insoluble, and this here is quite important. Barium sulfate is used as a barium meal and is ingested into the digestive tract. It absorbs X-rays and allows to observe the health of that digestive tract. However, it's important because it's nearly insoluble. Even though it's toxic, it's nearly insoluble, so there is no risk essentially. So that's quite important to know. If sulfuric acid is added to aqueous solutions of this, a white precipitate will be formed. Okay, so as we see here, it becomes sulfate ions. And as you can see here, they're quite of the larger group 2 metals, not quite the top, more so the bottom ones, okay? If dilute sulfuric acid also to the top ones, there is no reaction, and no precipitate. So it's more so the lower one, I guess. Quite precipitate formed are added to sulfate ions. Can be used as a test for sulfate ions. Yes, so you add dilute hydrochloric acid as well as barium chloride, and that barium reacts with whatever sulfate it is, forming barium sulfate, or white precipitate, and that is a positive test for that sulfate ion. And the hydrochloric acid removes any other ions such as carbonate or hydroxide ions which may affect the test. Trend in solubility of hydroxide. So we said as we go down the group, it's from least to most, so it increases descending the group. This is nearly insoluble, okay, but as you go down, it's very more and more soluble. If dilute, so yeah, insoluble, it will form a precipitate, a faint white precipitate for calcium because it's getting less and less, more and more soluble. And there is no reaction and no precipitate formed. Okay, so that's just something to note. Uses of sulfates and hydroxides. Magnesium hydroxide is for milk of magnesia and is used to treat indigestion, as it neutralizes the stomach acidity. So magnesium hydroxide neutralizes stomach acidity, H+ ions. That acid in the stomach, forming magnesium, this, and yeah, there we go. So calcium hydroxide is used as in acidic soil, used to neutralize acidic soil. Magnesium sulfate is used to counter magnesium deficiency. So magnesium hydroxide is for that indigestion. Magnesium sulfate is for that magnesium deficiency. Calcium hydroxide is used for acidic soil. Barium sulfate, we already told us, it was for the X-rays. And there we go. So that is quite important there. In fact, I will highlight it in green so that we do read through it before the exam. Okay, so I'm going to stop it here. Goodbye.